Okay, so I'm going to make you a short little video here to show you how to use the model kits and help you build and understand the shapes of molecules. So model kits look like this, and they come with little springs, and each color here corresponds to a particular type of atom. For example, red corresponds to oxygen, black corresponds to carbon, these yellows correspond to hydrogens, blues correspond to nitrogens, and we could use either red or purple or green. Actually can stand for any halogen that we would like. And I'll make sure that those get written on the board for you so that you can reference that as you go. We also have these little springs. Now, depending on how good of shape your kit is in, you should in theory have two types of springs, maybe some longer springs and maybe some shorter springs. Springs represent bonds. So I'm going to have you build several models, and I really do want you to actually build them. I think it's really important. And suppose, for example, we have to build H2O. Well, what we do is we get one red, we get two yellows, we get ourselves a couple of springs. I would try, just for the sake of symmetry and having the molecule look right, to get the same size springs. So I'm going to pick out two short springs here. Now your goal with these model kits is look at the pieces you've got, try to build the molecule, and if you build it correctly, there should not be any open holes. So water, I think most of us are probably familiar with what that looks like, but what I'm going to do is go ahead and take this, attach a hydrogen, take this, attach another hydrogen, and so here's my model, and there are no open holes. And if you are building your molecule correctly, there will be no open holes. And it will also automatically show you the shape of the molecule. So after you build it, what I'd like you to do is sketch as best as you can the shape that you see. So for example, what I'm looking at here is I'm seeing an oxygen, and I'm seeing two hydrogens kind of slanted down like that. So that looks about right. Also, I notice, my oxygen here, it's lacking electrons. It's sharing 4 electrons, 2 from this bond, 2 from this bond, so there must be 2 more pairs of electrons there, and so we have a nice Lewis structure for my molecule. Looking at another example quickly, let's try O2. Now, O2, I'm going to need 2 oxygens, and I can try to connect them with a bond, like this. And we see that that doesn't work out because there are open holes here, so we must have to do something else. And what we have to do is we have to add another bond, make a double bond. And then there we have it. Have a little oxygen molecule here. So I'm going to sketch that. Again, sketch it the way I see it as best as I can. I'm going to draw an oxygen. I'm going to draw 2 lines because there's a double bond here. And then also going to notice that each oxygen has 4 electrons the way I've drawn it. Each line counts as 2 electrons for each oxygen atom. So each oxygen atom then is going to need an additional 2 electrons. So it has 1, 2, 3, 4 electrons that it's kept. 5, 6, 7, 8. It's a total of 8. Everything's good there. And I have a good Lewis structure. So that's how you use your model kits. Now, one of the things that this page is going to ask you to do is to determine the shape of these molecules. So, a couple things about shape. When we determine the shape, we just want to look at the central atom. That's one thing that's important about shape. Another thing that's going to help you when you determine shape is to use this chart right here. So this chart is in the reference section. It talks about charge centers, lone pairs, and bonding regions. Down here is explained how to use this chart. What you start off by doing is look at the central atom only. And you're going to count the number of lone pairs on the central atom. So, for example, here is the water molecule that we've just seen. That right there is a lone pair, and that's another lone pair. So oxygen has 2 lone pairs on the central atom. Then we're going to look at the number of bonding regions. Bonding regions is anywhere where we see one atom bonded to another atom. It does not matter if it's a single, double, or triple bond. So if we look water over here, again, we're only paying attention to the central atom. That's all we're looking at. We don't really care what's going on with the hydrogens. There is 1 lone pair, 2 lone pairs. That's 2 lone pairs, and there's 2 bonding regions. So we consult our little chart here. Notice lone pairs in the central atom, bonding regions around central atom. Remember what we just figured out. For water, we figured out it had 2 lone pairs and 2 bonding regions. 2 lone pairs, 2 bonding regions is a shape known as bent, and that bonding was about 105 degrees. So if we want to identify the shape for water, it's bent. Its bond angle, if we're asked for that, technically I happen to know water's is 104.5, or about 105 degrees. Now, just as a kind of a side note here quickly, anytime there's only 2 atoms involved like this, or let's say maybe HCl, things like that, if there's only 2 things, all we can really have is linear. They're in a line, so that's something to keep in mind. We won't really find that on the chart. One more example here. CO2. So maybe we can see that, see if I can get a little bit closer. We're going to follow the same process. Now, I'll redraw it here maybe just a little larger, just in case we're having a little trouble seeing that. So we got the carbon. It's there in the center. So remember, we're only looking at the central atom when we use our chart. So I'm just going to kind of make a box just so that I'm really focusing just on the carbon. We're not paying attention to these oxygens out here. So we look just on the central atom. And we notice on the central atom there are 0 lone pairs. There are no lone pairs in this carbon. Yes, there's lone pairs in these oxygens, but that doesn't matter. There is no lone pairs on this carbon. Also, there are 2 bonding regions. That is a bonding region, and that is a bonding region. It does not matter that these are double bonds. It still counts as 1 bonding region. So this is the bonding region, this is the bonding region. So again, on our central atom here, we have 0 lone pairs and 2 bonding regions. Consult our chart. Lone pairs in the central atom, 0. Bonding regions around central atom, 2. That is a shape called linear. So that's how you use your model kits. That's how you determine your molecular geometry. Go ahead and make sure you build each and everything on there. I think it will really help you understand the shapes of these molecules as well as polarity.